Okay, let's define the Rolle's theorem. Rolle's theorem are kind of a very basic theorem in a calculus. In this theorem, it is saying that if any function f be a continuous means that we are a human, for example, we are breathing. If our breathing is stopped, then we will be dead. If we are saying ourselves a living human, then it means we are continuously breathing. So the function is be a continuous function, should be a living one, or it's in a working formation on the interval a to b. It means from point of birth to point of death. Both point are a to b, everything will be included. That continues from first breath to last breath. And differentiable, of course, this shows that changing from birth to death, humans, every living thing is changing. Okay, process of changing is there. On open interval, changing, see, once person is dead, no change. Once person is okay, came into this world, of course, itself it's after birth changing will start. So a and b are not included in this case. Differentiable, changing will start after the birth and before the death. Once someone is dead, there is no change. So this is the definition. Function be a continuous on the closed interval a to b, and differentiable. Differentiable is thing changing. Okay, changing on open interval ab such that there is another thing. Okay, for example, someone not existed in this world, we say the person is not living. Okay, so the first point, one person is dead, so still again he is not living, so both are the same. So if some function is continuous on the closed interval and differentiable on the open interval such that first and the last, okay, function at first place and function at last place both are the same, then at least one point, then at least one number, okay, one point, number c on the open interval such that, okay, in this case c such that change here in this, okay, change in this function equivalent to 0. Let me explain it with the help of mathematics theorem. So, okay, for example, there is a function x square minus 3x plus 2 . For this purpose, for understanding this, we say there was not no birth, or you can say that is equivalent to 0. So what we need to do, we need to just have this equation as it is, or we need to factorize. For determining, it will tell us the 2 points, okay, first and last, because without any change, remember, no change. So here x minus 3, similar, sorry, let me factorize it. It can be, okay, minus 3x minus x, so you can say x in, I calculated in the formation, x minus 1. If we factorize this equation, we have two factors, possible factors, x minus 2, or you can say x equal to 1, x equal to 2. This function have two possible values. Once you assume the activity of this function in, okay, no activity of this function, then two possible outcomes. So what are the possible outcomes? If we substitute 1 in this equation, in equation A, value of x equivalent to 1, answer will same. If we substitute the value of 2 in equation 1, answer will same. Let me check it. So by substituting the value here, this, okay, let me rewrite this. X cube minus 3x plus 2, and from the last this expression we get x equal to 1 and 2. So we will have two possible outcomes, x1, 2. Okay, let's suppose for x1, x equal to 1, f of 1 minus 3 plus 2, answer is what? Answer is 0. Let me select the 2, x equal to 2. So again, f of 2, okay, 2 2s are 4, 4 2s are 8, minus 3 into 2, 6. So answer is what? 0. Both the case answer is 0. So we can say f of 1, f of 2 equal to 0. If we plan it on a real line, okay, on x-axis, y-axis, suppose 1, 2. Let me make curve like this, for example, join, okay, change, okay. Remember, I told you people that function is continuous from continuous from a to b, and differentiable. Then in the close, okay, here let me, the continuous on this closed interval and differentiable on it. So from this point to this point, it is going, so continuous from A to B, it is reaching from A to B, and differentiable changing, every point changing from, okay, 1 and 2, basically 1 represent A, 2 represent B. So this is the differentiable on the open interval A to B. Now there is a sum point according to the definition. If f of A equivalent to f of B, both on x-axis, okay, both on x-axis. Here y is basically, this is what? Y. This is y at A, height y at B. Both are same. There is no change in y-axis. There is no change in y-axis. No change. No change in y-axis. Okay. This is y A. This is y B. Both are, you can say on x-axis it's 0. Just assume, okay, whatsoever. Value of x is 1 and other value is x equal to 2. So you can say another thing is 1, 2. Both are same. So situation is this. We need to, okay, if according to the definition, continuous, if function be a continuous on the closed interval and differentiable on the open interval, that is in this formation, f equal to f of A equal to f of B, y sub A equal to y sub B, then at least one number C, say A, B, okay, open interval, such that the derivative of that number C is some another number, okay, as I told you, some number between A and B. So between A and B, in this A and B, there, okay, we will calculate it, what kind of number it be. So we need to take the derivative. We need to take the derivative of what? Derivative of this equation. We need to take the derivative of this equation. F dash of x, then we will have 3x. Similarly, we will on minus 3, derivative of, okay, 3x square minus 3. So 3x square. No, not cube. It's wrong. It's square. Okay, square. Technically, there is square. Start. It's yes. It's square. It's square. Okay, it's square. It's square. So by substituting value here, okay, answer is even in I cube, but it's square. Let me check it out again. Square. Square. Okay, by substituting 1 minus 3 2s are 3 plus 2 equal to 0. So again 2. Here we will have 2 2s are 4. 4 and 3 2s are 6. Okay, so this is a little typo. So the answer is 4 plus 2. So 6 minus 6 equivalent to 0. So please make it correct. Thank you. So we are here 3x square minus, sorry, let me fix it again. Two x minus 3. Let's the change, okay, f equal to 0. So we will have 2x minus 3. So x is what? 3 over 2 or 1.5. Okay, let's go back to the this. That if you start, you are okay 1.3. This, for example, there is somewhere C, and value of C is 1.5. You can check it's 1.5 by this change. Okay, considering critically equivalent to 0, we will have x equal to 1.5 on x-axis. See that C equal to midpoint between A and B. You can check that if you travel from A to C, it is the 1.5 and again 1.5 somehow. No. So basically this point. So at this point C equal to, okay, this point 1.5. If you start from this to here, at this point you are covering the same distance to reach here. So C is the midpoint between A and B. This is the Rolle's theorem. Concept is if the start and the end point are the same, then there is some point in between two values. That's the average of two, or you can say mid of the two. Rolle's theorem is telling us that is rolling. Okay, rolling somehow between the two fixed values. Rolling between two fixed values.